I'm William Michael of the Classical Liberal Arts Academy, and in this lesson we begin the study of Algebra I that is, in the Classical Liberal Arts Academy. And what I'd like to do in this first video is provide a walk through the first few articles of this first lesson to make sure that everything is crystal clear for students getting started in algebra. It's very important for us to understand, if you look at the top of the page here, we see that the first set of articles we study cover a number of definitions. And why this is so important is because we're being told here by the author of the textbook what these words mean. And anytime we see these words used in this textbook, we're to think back and remember how they were defined in these first lessons. So we're going to take some time to carefully study the definitions of these important words to be used in the study of algebra. In this first article, we have not a definition, but a description of algebra itself, the subject of this study. We read, "In algebra, quantities are represented by letters of the alphabet." In algebra, quantities are represented by letters of the alphabet. And you should note that that's something strange. In arithmetic, we never represent quantities with letters of the alphabet. We represent quantities with numbers. But in algebra, we're doing something different, and we're going to talk about this as we get started and as we continue through the study of algebra. We're not doing in algebra the same thing we did in arithmetic. We're doing something different, something that's very important and will help us in other studies. We'll talk about that later. But in algebra, quantities are represented by letters of the alphabet. Now, in that definition, or a description I should say, we find the word quantities, and we may want to know what exactly is a quantity. What exactly is a quantity? And here in Article 2, we're going to find the definition of a quantity, and then in Articles 3 and 4, down here, we're going to learn about the two kinds of quantity. So in Article 2, we have a definition of quantity. And then in Article 3, we learn about magnitude. And Article 4, we learn about multitude, which are the two kinds of quantity. So let's look at Article number 2. A quantity is anything that is capable of increase or decrease. Quantity is anything that is capable of increase or decrease. Anything that can grow or diminish, that can get larger or smaller, greater or fewer. Anything that can increase or decrease is said to be a quantity. And like I said, there are two kinds of quantities. In Article 3 we read, "Quantity is called a magnitude when considered in an undivided form." Quantity is called a magnitude when considered in an undivided form. Another way we can express this is as a whole body. So when a quantity, something that can increase or decrease, is a whole body, an undivided form, we call that quantity a magnitude. Article 4, a quantity is called a multitude when made up of individual and distinct parts. A quantity is called a multitude when it is made up of individual and distinct parts. A quantity is one body. A multitude, or I should say a magnitude, is one body. A multitude is a collection of individual bodies, individual and distinct parts. A magnitude is one body. A multitude is a collection of bodies. Those are the two kinds of quantity. So here in Articles 2, 3, and 4, we have the definition of quantity, and we learn about the two kinds of quantities. And these are the only two kinds. So you should understand that magnitude and multitude are the two kinds of quantity. Let's move on to Articles 5 and 6. Now, when we learn about quantities and the different kinds of quantities, we learn that they can increase or decrease. We may want to measure these quantities. And so the question arises, how can we measure these two different kinds of quantities? How can we measure a multitude? How do we measure a magnitude? And we have the answer to those questions in Articles 5 and 6. In Article 5, we learn how to measure a multitude. How to measure a multitude. Let's read Article 5. One of the single parts of which a quantity of multitude is composed is called the unit of measure. One of the single parts of which a quantity of multitude is composed is called the unit of measure. So when we talk about a multitude, and we say that a multitude is a collection of individual parts, one of those parts is called the unit of measure. One of those parts is the unit of measure. We have an example given here in Article 5 about a number of cents or coins. If we had a collection of pennies, we would have a multitude. If we asked, what is the measure of this multitude? How do we find the value of this multitude? We would simply take one penny as the unit of measure, and we would count how many pennies are contained in the multitude. Finding the value of a multitude is very simple. We simply count the number of units in the multitude. In Article 6, we learn how to measure a magnitude, and this is a little more complicated. In quantities of magnitude, notice it says, where there is no natural unit. Where there is no natural unit. What that means is, in a multitude, the natural unit is the individual thing that is collected together in the multitude. In a magnitude, there's only one thing. A magnitude is an undivided form, or a whole body. So in a magnitude, there is no natural unit. How then do we measure a magnitude? In quantities of magnitude, it is necessary to fix upon an artificial unit. It is necessary to fix upon or choose an artificial unit. And what artificial means is that we can make up a unit. We can make up a unit. We can make up any unit we please. But we need to choose a unit that we're going to use as a standard of measure, and then to find the value of the quantity, we ascertain how many times the magnitude contains its unit of measure. So we choose an artificial unit, anything we please, and then we count how many times that artificial unit is contained in that magnitude. So we use a different method to measure a magnitude than we do to measure a multitude. Let's look at an example. Down here at the bottom of Article 6, we read down here, to measure the length of a line, this is an example of a magnitude. A line is an undivided form, a whole body. To measure the length of a line, what do? We take a certain assumed distance. A certain assumed distance, that's the artificial unit of measure. We can use a foot to measure a certain line, and we take the foot and we apply it a certain number of times to count how many times that unit of measure is contained in the line. So if the line is 5 feet long, it means that the line contains 1 foot 5 times. That's how we measure a magnitude. We choose a unit of measure and then use that unit of measure to measure the whole magnitude. Moving on here down to Article 7, the numerical value. The numerical value of any quantity, that is a magnitude or a multitude. The numerical value of a quantity is a number that shows how many times it contains its unit of measure. The numerical value of any quantity is the number that shows how many times it contains its unit of measure. Thus, the numerical value of the line that was 5 feet long, here we have the measure of that line. The number that shows how many times, which is 5, this number 5 is the numerical value of that quantity. The numerical value, just the number, the numerical value. The numerical value of this quantity is 5. Now, that same line, we read here, that same line can have a number of different numerical values. The same line can have a number of different numerical values. How can that be? How can the same magnitude, the same quantity, have a number of different numerical values? How can that be? If we use a different unit of measure, the numerical value will be different. So here in the example, we chose to use 1 foot. But what if we chose to use inches? If we measured the same line, but used 1 inch as the unit of measure, we would find that the line was 60 inches long. And the numerical value of the quantity would be 60. So the same quantity can have a number of different numerical values if the unit of measure changes. And moving on now to Article 8, we read, a unit is a single thing of an order or kind. A unit is a single thing. So anything that we refer to as one of anything, anything we refer to as one is a unit. And in Article 9, a number is an expression denoting a unit or a collection of units. A number is an expression denoting a unit, since a unit is one, or a collection of units, any number more than one. A number is an expression denoting a unit or a collection of units. A unit is what we call one. A number is an expression denoting one or more units. How many units? That's a number. And here we learn in Article 10, I should say, it's got two parts to it. We learn that there are two kinds of numbers. Numbers divide into abstract and concrete. Abstract number and concrete number. We read in Article 10, an abstract number denotes how many times a unit is to be taken. And the reason why that's in italics there is because this to be taken, the word abstract comes from Latin, and in Latin it means taken away. Abstract means to take away. It means to take something away from physical or material reality that we can touch, taste, look at, handle, and so on, and to simply think about the idea that's present in that material thing. Abstract means to take away from material things, to think about something, an idea abstracted or taken away from material things. An abstract number denotes how many times a unit is to be taken. A concrete number denotes the units that are taken. A concrete number denotes the units. So the concrete number tells us the number, but also what the units are. An abstract number speaks of the number alone, without any reference to the units. An abstract number doesn't tell us what. An abstract number tells us how many. A concrete number tells us how many what. So an abstract number simply tells us how many. A concrete number tells us how many what. 4, as an example, is an abstract number. It denotes merely the number of units taken. 4 is an abstract number, the number by itself, taken away from the material, taken away from the unit of measure. 4 feet. 4 feet is a concrete number because it tells us how many and what. 4 feet. How many? 4. That's an abstract number. How many what? 4 feet. That's a concrete number. So 2 kinds of number: abstract number, which is just the number by itself, and concrete number, which is a number and a unit of measure. So far in this lesson, we've studied the first 10 articles, and we're going to stop here in this video. What I'd like you to do is take time, go back and study these first 10 articles on your own. Make sure that you memorize these important definitions because, as I said, the author of the textbook is telling us here how these words are going to be used throughout this book, and these definitions are very important. Most of the problems that students have in algebra are caused by not carefully studying the definitions. When students get into later lessons in the course, they forget the definitions and begin to make mistakes and get confused because they don't remember the words and the meanings of the words that were taught to them in the beginning of the study. So take your time, master these definitions, and you'll build a strong foundation to start building your knowledge of algebra. I hope this video has been helpful. If you have any questions about anything in these first 10 articles, get in touch. I'm happy to help. God bless your studies.